Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over practice problems on predicting the products of reactions. So let's get into this. So the first problem is that we have sodium plus oxygen yields something, right? So we're given in words that sodium is put together with oxygen, so we need to write down the formulas from the words. So we write down Na for sodium, and that's going to be solid, and oxygen. And so we need to remember that oxygen is one of the diatomic elements. So if we do plus O, that would be wrong and would lead us to the wrong answer for the balanced equation. So here it has to be O2 because oxygen is a diatomic element. It exists as a diatomic molecule. Okay, so here are the reactants. So we need to identify this reaction. So what kind of reaction do we have? Is it synthesis combination? Is it decomposition? Is it single displacement combustion? What's the case here? So here you'll notice that we have sodium and oxygen. We have a metal and we have a non-metal. And so and they're both elements. So it looks like the two elements would have to become together to form a substance, right? So our first inclination would be that this is a synthesis or combination reaction because we're starting with two elements, and these elements can only do one thing, they can combine. So we would expect, since we have a metal and non-metal, that this is going to produce an ionic substance, an ionic compound with both elements. So we can do that. But also notice one of our reactants is oxygen. So therefore, this is, to be more specific, this is a combustion reaction because we're reacting with oxygen. But we're still going to form an ionic compound. So to predict our product, since we have a metal and a non-metal, we need an ionic compound that has sodium and oxygen in it. And this is where we need to know our ions. We need to know what the charges are going to be on these particular elements. Sodium, since it's in a group 1, it's group 1A, we know that it must have a +1 charge. We also know that because it only has one valence electron, and it will give away that electron in order to be like a noble gas, to have a stable full shell. So, and that's what gives it its +1 charge. Oxygen is in group 6, so it will gain 2 electrons. So it has 6 electrons, 6 valence electrons. It wants 2 more, so it'll gain those 2 electrons and get that -2 charge, and it will be have a complete outer shell, and it will be stable. So we're looking at a substance as sodium with a +1 charge, oxide ion with a 2 negative charge. So when we put those together to balance the charge, so remember, if we're balancing the charge, we have Na plus and we have O2 minus. So those are the ions involved. And we do the crisscross method. So the 2 becomes a subscript for the sodium, and the 1 here is a subscript for the oxygen. We don't write ones, so the product would have to be Na2O. So that's our product, that's our neutral product. So this is going to be Na2O for our product. So now we have our product. And so the only thing we need to do now is to balance the equation. So don't forget our states of matter. So we have 1 sodium here, we have 2 there, so we should have a 2 in front of our sodium. And we have 2 oxygens here, right? So we have 2 oxygens, and we only have 1 oxygen there, so we should put a 2 there for the oxygen. Oh, I forgot to show you a little trick here. Okay, so here we left oxygen by itself. So because we have this by itself, oxygen, usually you want to leave oxygen last. And so what you could do here is we have one oxygen here, we have two here. So what we could do is figure out, well, what times two will give me one? Because I want a one there. So let's say I want a one there, right? So this is why we want to leave the oxygen as last, or if you have a pure element, leave that as last, because now we can work with this and we can use a fractional coefficient to balance the equation. So here, if I want to have a 1 here, just like I have a 1 here, I want one oxygen. Well, what times 2 gives me 1? That would be 1/2. So if I did 1/2, right? So now I have 1/2 of 2 is 1, and I have 1 here. So now the equation is balanced. So everything's balanced, but you're like, well, Mr. Kova, we're not allowed to have half of fractions. We can't have that, can we? It's like, yeah, you'd be right. So we need to, even though this is balanced, we need to get rid of that half. So how do we get rid of the half without undoing the balance of the equation? Well, this is where you get to multiply the whole equation by a factor to get rid of the half. And so what can we multiply 1/2 by to get rid of the half? 2. So if we multiply everything by 2, we'll get rid of that half. So 2 times 2 is 4. 1/2 times 2 is 1. You don't write the ones. And then 1 times 2 is 2. So now we have our balanced chemical equation. And so again, this is going to be combustion. So it's a combustion reaction. It's also synthesis because if you're adding these two together to form one product, so 2 goes to 1. But the more accurate description is that it's a combustion reaction. So this belongs in the category of combustion reactions. Okay, what about sodium chloride? So we have number 2, sodium chloride breaks into its components. So what does that sound like? That sounds like decomposition. So decomposition, let's write that down. So here, looks like, all right, here, decomposition. So it looks like we have a decomposition reaction. So let's write down what we have. So sodium chloride. So we need to translate that into its formula. So we need to go from the name to the formula. Sodium is Na plus and chloride. So again, we want to make sure we're getting a neutral compound. So we write down the 2 ions from the name. So sodium and chloride. So you can see that sodium and chloride, they both have a -1 and +1. So that is going to balance out. So if you do the crisscross method, 1 and 1, they become subscripts. So it's just 1 each. So we don't need subscripts for our compound. So NaCl is the compound. Breaks into its components. So what are the components? Sodium and chlorine. So this is a solid, and that's going to break up into sodium and chlorine. And again, chlorine is one of those diatomic elements, so we need to write it as Cl2, not Cl, but Cl2. And Cl2 is a gas, so that'll be G for gas. Sodium is a metal, so that's going to be a solid. And so now we have our equation. So this is a sodium chloride, a compound, an ionic compound breaks up into its individual elements. And so we got sodium and Cl2, Na and Cl2. And so now all we need to do is just balance the equation, make sure it's balanced. So here we have 1 sodium, 1 sodium. So that's good. Start with the metals. And then the non-metals, we have 1 chlorine and we have 1 chlorine here. But again, we can balance this with a fraction. So if I have 1 chlorine here, I want 1 there. What times 2 gives me 1? 1/2 again. So I have half of there. And so now it's balanced. So 1/2 of 2 is 1. So I have 1 chlorine on this side and 1 chlorine on this side, but I cannot keep that fraction there. So to get rid of this fraction, to get rid of the half, I multiply by 2. So I have to multiply my whole equation by 2. So 2 times 1 is 2. 2 times 1 is 2. And 2 times 1/2 is 1. So we don't write the ones, and we'll keep it that way. Sorry about that. The light went off again. All right, so now we have our balanced equation. And again, this is an example of a decomposition reaction. Okay, what about number 3? Number 3, we have aluminum. Aluminum is added to lead 2 nitrate. So we have a lead 2 nitrate here, and we have aluminum. This is most likely going to be a solution, an aqueous solution here, lead 2 nitrate, and we're adding aluminum. Aluminum is a metal, so that's a solid. So let's write this in terms of our formulas. So aluminum is just the metal on the periodic table. So we have Al for aluminum. That's going to be solid plus. And then we have our lead 2 nitrate. So again, we want to write the formula and make sure the formula is balanced in charge. It's a neutral compound, so 0 charge for our formula. So again, for lead 2, the lead 2 ion is Pb2 plus, and nitrate is NO3 minus. And so again, to get our formula, we can do the crisscross method. So the 2 here will become a subscript there. And we have a 1 here. That's going to be a subscript there. We don't write the ones. So our product is going to be Pb, or I should say our reactant is going to be Pb. And then since we have 2 here, we're going to need parentheses, NO3 2. So here's the formula of our neutral compound. So that's going to be Pb NO3 2. And this is going to be aqueous. So this is dissolved in water. Aqueous. It's a solution. Okay. And so then we got to predict the product. So what kind of reaction does this look like? We have an element by itself, a pure element, and we have a compound that has 2 parts to it. This is an ionic compound, 2 ions. So we have a metal, and we have an ionic compound with a metal. So you should be thinking, oh, this metal could replace that metal, so this could be a single replacement reaction. So this looks like a single displacement or single replacement reaction. So I'll put single displacement. So single displacement for this one decomposition, this one combustion. All right, so we would have to determine if aluminum is higher on that activity series. So remember, when you're trying to figure this out, the activity series, the activity series for metals is what you're going to look at. So aluminum, if aluminum is higher on that activity series than lead, then you would expect aluminum to kick off the lead, and then lead would be by itself as a product, and then the aluminum nitrate would be the other product. So we would replace that. So we would get aluminum nitrate, NO3, And since we want, again, we want these products to be balanced, we go back here and we look at, okay, well, aluminum is 3 plus, and we have the nitrate again. So nitrate is NO3 minus. And so again, we do the crisscross method. So this 3 would go down here. This 1 would go here. So we'd end up with aluminum. And this time we have 3 nitrates. So it's NO3 parentheses 3. So there's our product with balanced charge. So this would be our neutral product. So we're going to have a 3 there, like that. And again, this is going to be aqueous. And finally, our lead was kicked off, so that's going to be by itself, Pb, and so that's going to be a solid. So this is this exists as a solid because it's a metal. And so now we have our balanced equation here. Now, we're not done because we have to identify what are called the spectator ions, and we got to get rid of those. So how do we do that? So I'm going to erase this. And so we have our balanced equation. Oh, wait, we need to balance the equation before we do this. So let's double check. So I have, we'll start with the metals. I have aluminum here. I have one aluminum, so that's balanced. I have one lead here, and I have one lead there, so that's balanced. And so we look at the nitrates. You'll notice that I have 2 nitrates here, but I have 3 nitrates here. So I need one more nitrate on this side. So the easiest way to do this is if I can make a 2 here. So if I put a 2 here, I have 6 nitrates. And so if I put a 3 here, so 3 times 2 gives me 6 nitrates. 2 times 3 gives me 6 nitrates. So now I have balanced nitrates, but my aluminum and my lead is unbalanced. So I have 2 aluminum here, so I should put a 2 here for the aluminum. I have 3 lead here, so I should put a 3 here for the lead. And now everything is balanced. Okay, so what do I do from here? So the first thing I want to do is from this molecular equation, I'm going to write what is called a complete ionic equation. And what you do there is you just write everything, all of your aqueous ion solutions, those ions are written apart. Anything that's solid, liquid, or gas stays together. So this aluminum stays together. So I'll write this here. So I have 2 aluminum solid plus, and then I have this aqueous ionic solution. So these ions are really just floating around in solution. They're not actually together. We write it together because that's the formula, they balance charge. But in reality, these ions are dissolved in water. Aqueous means dissolved in water. So they're not together. They are separated, floating around in solution. So what we can do is separate out these ions. So since I have a 3 here, that applies to everything. So I have 3 lead. So I'm going to put 3 Pb 2 plus because the ion has a 2 plus, and I put aqueous. And how many nitrate ions do I have here? 3 times 2 gives me 6 nitrates. So I have 6 plus. So 6 NO3 minus aqueous. So these have been split apart. So in solution, I have 3 lead ions and 6 nitrate ions. So those are my reactants. And then I do the same thing for the products. So again, I have aluminum nitrate, in solution. So this is an aqueous solution. It's ionic. So these ions, again, are separated from each other. So I have the Al3. So I have Al3 plus aqueous. And then I also have the nitrate. So again, I have 2 times 3. That means I have 6 nitrates. So I'm going to write down here the rest of it. So I have 6 NO3 minus aqueous. And then I have my 3 lead atoms. So that would be plus. I'll put a plus there. So here. And then I have my 3 PB2 plus. So here are my products. So the aluminum 3, the 3 plus ion. So the aluminum ion is aqueous, floating around in solution. I have my 6 nitrate ions floating around in solution, and then I have my lead plus my 2 plus ions floating around in solution. So this is what is called the complete ionic equation. So now what do? So I want to eliminate what are called spectator ions. And the spectator ions are the ions that are not doing anything. So if you look at both sides of the equation, before and after the arrow, so on the right side and left side of the arrow, you're looking for the ion that doesn't change. So if it's aqueous on one side and aqueous on the other side, then it didn't change. So you'll notice here that aluminum goes from 0 charge solid to a +3 charge. So that changes, so that is not a spectator. Your lead goes from a 2 plus charge here. Oops, I forgot to change that. That should be a solid. So your lead goes from having a charge to not having a charge. Here we have solid, here we have aqueous, so that is not a spectator ion. Here we have 6 nitrates aqueous, and here on the reactant, on the product side, we still have 6 nitrates aqueous. So that is a spectator ion. So we want to get rid of the spectator ions. So we'll get rid of this. And so what that leaves us is with our final equation, which is called the net ionic equation. So the net ionic equation, the final one, is going to be the whatever's left over. So 2Al solid plus 3 PB2 plus aqueous goes to aluminum 3 plus aqueous plus 3 PB solid. Oops, let me rewrite this so it's better so you can see it. So here we have the Al3 plus aqueous plus, and then we have the 3 PB solid. So this would be our final equation for the reaction. And again, this is a single displacement or single replacement reaction. Okay, what's next? So we have PbNO3 and Ki, potassium iodide. So what are we going to do here? So again, here you can see that we have 2 ionic substances. So they're both ionic compounds. So we're looking at a double displacement reaction. So here we're going to do our inside ions and our outside ions. So the nitrate is going to go with the potassium, and the lead is going to go with the iodine. So we take the 2 inner ones. That's going to be potassium and nitrate. So KNO3, because remember, potassium is a plus NO3 is a minus. So we do our crisscross method. They're one each. So we just need one each. So KNO3 is the neutral compound. This is going to be aqueous, right? So that's going to be, let's write it over here. So we have KNO3 aqueous, or we'll figure that out in a moment, whether it's aqueous or not. And then we put the outside ions together. So this is a lead 2 plus. How do I know this is lead 2 plus? Because I have 2 there. I know the nitrate is a -1, so that means I have 2 nitrates. That's a -2 charge. And so I need a +2 charge to balance that out. And since I only have one lead here, lead atom, that 2 charge has to be on the lead atom. So this is lead 2. So if I match that with iodine, so I have lead 2, Pb2 plus, and then the iodide ion is a -1. So again, to write the neutral compound of these two, I do the crisscross method. So 2 goes there, and 1 goes there. So this is going to be PbI2. And so this is what we have so far. So now all we need to do is make sure we balance the equation. So I have one lead, so that's good. Here I have 2 nitrates, but I only have 1 nitrate here, so I need to put a 2 there. Here I have 1 potassium, but now I have 2 potassiums there, so I can put a 2 there. And here I have now 2 iodide ions, and here I have 2 iodide ions. So now I have my balanced equation. So now the next thing is to, again, I have to determine whether or not I have a precipitate here or not. So I have to use my solubility rules. So one of the things I've learned is all nitrates are soluble. So this is a nitrate, so this is soluble, so that's going to be aqueous because that's what the solubility rules say. So this is soluble, so that's aqueous. And then when I look at my solubility rules, I know that iodide this ion is soluble usually, but one of the exceptions is the lead 2 ion. So this is going to be a solid. So it is a precipitate. So this is insoluble. Again, iodides are usually soluble generally, but this is an exception. The lead 2 ion is an exception. So this is insoluble. It's going to be a solid. So this is my precipitate. And so now I have my balanced equation. I have my products. And now what I do is I need to eliminate these spectator ions. So once again, I have to write out my complete ionic equation. Anything that is aqueous. So these two, I forgot to put these in. These two are aqueous. So I'm going to spread these out into their ions. So the Pb, so these are aqueous, so they're going to be separated. So I have Pb2 plus aqueous. And then I have 2 nitrates here, so that's going to be 2. I take the subscript and write it as a coefficient. So that's going to be 2 nitrates, NO3 minus aqueous. And then I do it with the potassium iodide. So I have 2 here, so I have 2 of both. So that's going to be 2K plus aqueous plus, and then 2 iodide ions. So that's going to be 2I minus aqueous. And so there I have that separated. And so next I'm going to do the products. So I'm going to separate these into its ions. Notice that this is a solid, so it's not going to be separated. And so I'll continue this in my next video. So if you like what you see so far, please make sure you like this video, hit the notification bell up there, subscribe to my channel. Thanks for joining me. I'll see you again.